Alright students, here's your Unit 7 Vectors Review for Wednesday's exam. The exam is scheduled for this Wednesday, May 15th, during your normal class period. So first problem set says find and draw the vector v with initial point P and terminal point Q. Also find the magnitude of v. On this first one I'm going to plot P at 2, 1. I'm going to then plot Q at 5, 5. I'm going to draw that vector. And then I'm going to calculate the magnitude. So that is vector v. Its magnitude is calculated using our magnitude formula, which essentially is just the distance formula. So that would be the difference in the x values using the terminal point minus the initial point x value, and then squaring that quantity, and then adding that to the difference in the y values. So 5 minus 1. Take that quantity and square it. That's going to give us the square root of 3 squared plus 4 squared, and that's going to give us the square root of 25, which therefore the magnitude of this vector is 5 units. Okay, letter B, let's plot point P, -4, 1, and Q is at 1, -3, so that vector can be drawn as such. Again, that's P and that's Q. Go ahead and label my points over here as well. So P and Q. To calculate the magnitude of this vector, we use the same process. That's the square root of the difference of the x values, terminal point minus the initial point. And then we're going to square those values, and we're going to add that to the y value difference, and make sure to square that difference as well. That gives us the square root of 1 minus a -4, so that gives us 5 squared plus -3 minus 1, well that's -4 squared. So that's 25 plus 16, which is the square root of 41. So square root of 41 there. That's the magnitude of that vector. Letter C, why don't you try that one on your own and then check in with me. I'll show you the answer in class, but work on letter C, do that one on your own. So let's scroll down and look at problem set number 2 for this section. Given the vectors u, -3, 7, and v, 5, 1, find the following. So letter A is just multiply vector u by scalar -1/2. So essentially here what we're going to do is we're going to multiply, distribute -1/2 to the x component and to the y component of this vector. Well, using distribution, we get -1/2 times -3, which is 3/2. And -1/2 times +7, which is -7/2. That's the resulting vector, -1/2 times vector u. Looking at B, here we're going to take the sum of the two vectors u and v. So what we're going to do here is we're going to add the x components of the two vectors, and then we're going to add the y components of the two vectors. So the result here is just -3 plus 5, comma, 7 plus 1. So taking a look and adding those components together, we get -3 plus 5, which is 2, and we get 7 plus 1, which is 8. So this is the sum. This resultant vector is the sum of vector u plus v. Here in D we have the difference of two vectors after they've been multiplied by scalars. So vector u has been multiplied by the scalar 3, and v has been multiplied by the scalar 4. You can also think about it as the sum where vector v has been multiplied by -4. I'm going to treat this as a difference, and I'm just going to multiply by the positive value of these two vectors here. So what I've got going on is 3 times u, that is -9, comma, 21. So 3 times -3 and 3 times 7. And then I'm going to subtract 4 times 5, which is 20, and 4 times 1, which is 4. Now simply just subtract negative 9 minus 20, which is negative 29, and 21 minus 4, which is 17. So the resulting vector there is the vector with components negative 29, comma 17. Now let's look at problem set number 3. So problem set 3 asks us to find a unit vector in the direction of the following vectors, and then also to show that it has length 1. So in order to find a unit vector, first you need the magnitude of that given vector. So the magnitude of v here would be the square root of the squared components. So negative 3 squared plus 4 squared. Well, that ends up giving you 9 and 16, which is the square root of 25, and we're pretty familiar with that. That's going to give us 5. So the magnitude of vector v is 5. In order to find the unit vector, okay, so I'm going to call the unit vector here u. Well, that's just v divided by its magnitude. The components of v divided by the magnitude. So that's going to give us negative 3 divided by 5, and then the y component, 4, divided by the magnitude, which is 5. That's the unit vector in this direction of vector v, negative 3, 4. To show that vector u has length 1, all I need to do is find the magnitude of u. Well, the magnitude of u would just be the square root of negative 3/5 squared plus 4/5 squared. Well, do the math there. You get 9 over 25 plus 16 over 25, square root of all of that. Add those together, add the numerators, keep the same denominator. You end up getting 25 over 25. Last time I checked, number divided by itself is 1. Square root of 1 is 1. So we just showed that the magnitude of this vector in the same direction as the original vector is 1. This is a unit vector in this same direction. Vector v here in letter B, let's try the same process. Find the magnitude of v. Pretty simple this go around. You square those two components. Well, negative 4 squared is 16 and 0 squared is 0. So essentially we have the square root of 16, which is 4. Now take vector v, divide that vector by its magnitude to find the unit vector in the same direction, and that's going to be negative 4 divided by 4 and 0 divided by 4. Pretty simple one to work with. Negative 4 divided by 4 is negative 1. 0 divided by 4 is 0. Now let's show that u has magnitude 1. Find the magnitude of u. That's the square root of negative 1 squared plus 0 squared, which is the square root of 1. And we know from seeing here, square root of 1 is just 1. So I've shown that vector u here is a unit vector in the same direction as vector v, and it has magnitude 1. So that wraps up problem set number 3 in this review. Let's look down at problem set number 4. It says write vector v given its magnitude and the angle it makes with the positive x-axis. Essentially here I want you to give the x and the y components of this particular given vector. This vector has magnitude 5 in this case, and it has direction angle 0. Well, sine and cosine are going to be big deals in this case. So in order to write this vector, the x component is going to be your magnitude times the cosine of the angle. So here it's going to be 5 cosine 0 degrees, and your y component, as you may have guessed at this point, is going to be 5 sine 0 degrees. Go ahead and simplify. So cosine of 0 degrees is 1, so that's going to be 5 times 1. Sine of 0 degrees is 0. 5 times 0 is 0. So there's your vector written in component form with your x and y components. Letter B, we have magnitude 8. We've got a direction angle 30 degrees, which is on your unit circle. So that's going to help out in a moment. We're going to multiply magnitude times the cosine of the angle That gives us the x component. Magnitude times the sine of the angle. That gives us our y component. Now go back to your unit circle. You're going to end up having 8 times cosine 30 degrees. Well, that's 8 times root 3 over 2. And you get 8 times sine of 30 degrees, which is 8 times 1/2. That gives us, well, 8 divided by 2 is 4, so that's 4 root 3. And 8 divided by 2 is 4. 1/2 of 8 is 4. So there's that vector. It has magnitude 8, direction angle 30 degrees, written in component form.